Hello everyone. In this video, I am going to show you the execution of the RISC processor. Here I am going to execute a program and show you in the RISC processor how it executes by using RIPES application. Firstly, my program is about the addition of n numbers. Here I have taken the n as 10. Let's see the program. I have initially two values. One is x1, other one is x2. X1 is 0 and x2 is 10 here. I hope you will know about the addition operation, right? So let's see what is adding. Here x0, the register value is defaultly set as 0. Next, about add I. What is add I is nothing but we are immediately taking a value and we are adding it with the register x0 and we are storing it in the x2. This is what the add I operation will perform. Thus, we have set it the x1 and x2. Next, we will go for the summation, that is addition of 10 numbers. Firstly, x2 will provide you with the final output. Sorry, x1 will provide you with the final output. x2 will be the decrementing of the value, that is 10, 9, 8. Likewise, it will be decremented like that will be performed in the second line. Next, that is in the fifth line. Next, the sixth line will be performed BNE operation. What is BNE? BNE is nothing but branch not equal. That is, it will check a condition and if it is satisfied, it will provide with a looping. Not, it will halt the looping. So here, we will check whether x2 is equal to x0. That is, x2, what is the value of x2? It will be the decremental value. What is x0? It will be 0, right? So it will check whether x2 is not equal to 0 or equal to 0 or not. If it is, it will halt the loop. If it is not, it will provide with the looping. If it is equal, it will halt. If it is not equal, it will provide with the looping. Got it? So here, what is the branch? Branch is the set of instruction, right? Okay. So thus x1 will be provided with the output of addition of 10 numbers, that is output as 55. So it will be just stored in x1, right? If you want to print it out, we will be using x, we will be using the other statements here up to 10 to 11 will perform the operation of printing the x1 value. Here x1 is 55, right? We are moving it to the argument. What is the argument? Is here we are taking it as a naught. Next, we will ask the system call to print it. Got it? So to print an argument, we need to use a system call 1. So if we call 1 to the system will assume and will print the value of x1. That's it. Okay, let's go for the execution of this program. So this is the RISC processor. Here it will perform the addition of operation up to n1. So the looping will be performed in 10 number of times and it will be provided with the result. That is, it will just store it in the x1. If we want to print the output, it will be shown in the console here and thus the output is shown as 55. Got it? That's it. Since we have seen the execution of the program, let's also see the hazards which have occurred in this execution. I think you may know what is hazard. So hazard is nothing but a problem which occurs during the execution of the program or instruction, which slows down the performance of the CPU. There are three types of hazards. I think you may know about that. That is structural hazard, data hazards, and control hazards. So in our program, we are encountering with two types of hazards. One is data hazard and other one is control hazard. So where does the data hazard occurs? Yes, I think you may get it. It occurs in fetching the data, that is x1 and x2 depends on the previous values too, right? While you will add uh, performing in the loop operation, you will need the x2 for the other instruction to perform. So the one instruction is depend upon the other instruction, that is the value is depending upon the other, right? So this is known to be the data hazard. So next, in our program there we encounter control hazard too, which is occurring in the looping statement, where the pipeline of the instruction may be fetched wrongly. That is, the pipeline may fetch any instructions wrongly. So that's what is occurring here, where in BNE, the loop statement, in that instruction. So I have shown you the execution of the recipe processor by using the program addition of 10 numbers. Thank you for watching this video. See you then.